Afternoon again, and welcome to this Pipeline Industries Guild webinar. And for those of you who don't know me, I'm Norman Howell. I'm the CEO of the Guild. And today's webinar on the Pattaya storm outfall will be presented by Simon Thomas, who is the Managing Director at Asset International Limited and is an international business consultant with over 25 years experience in the manufacture of thermoplastic structured walled pipes. He helped to introduce the first large diameter HDPE structured wall products into the UK, developing the Weholite HDPE structured wall pipes into one of the most recognizable brands in the industry. And the project we're going to see today involves the construction of a 1,015 meter long DN1800 Weholite HDPE structural wall pipe marine outfall with a diffuser section. And this outfall was to prevent flooding of the city of Pattaya, located in Thailand. And Simon's going to outline the challenges that the construction team faced to deliver the project within a fairly tight delivery program in what is a tourist city. And it was during high season when the beaches couldn't be closed for long periods. And in addition, he's going to provide us with details of how his team overcame the challenges posed by the global pandemic to successfully complete the installation on schedule. Just before we start, I'd just like to advise you of a few housekeeping rules. Can you please keep your camera off and your microphone on mute? There will be opportunities to ask questions after the presentation is completed. So to help us to manage that Q&A session, can I ask you to post your questions within the chat function? And then also just for you to note that the webinar will be recorded and we will be posting it on the Guild's YouTube channel in a few days' time. So without further ado, I'll pass over now to Simon to provide us with his presentation. So over to you, Simon.
Okay, good afternoon, everyone. Thank you very much, Norman, for that introduction. As Norman has explained, I'll be telling the story of the installation of the Pattaya storm outfall. It's not a groundbreaking marine installation by any means, but still it was a difficult installation given goings on in the world of the last 2 years. If nothing else, I'm sure you'll get to see some beautiful beach photographs, which may help to warm you up during these cold December days that we're getting at the moment. So just a little bit of background information. First of all, Pattaya lies on the east coast of the Gulf of Thailand. The population is approximately 100,000 people, which is relatively small when you compare it to the tens of millions of tourists that visit there each year. It started life as a small fishing village, but it's become one of the most famous and popular beach destinations in the whole of Southeast Asia. And obviously that means that tourism has such a massive impact on the city's economy. So keeping the beaches and streets clean is vitally important, both to the local residents and the tourists that visit there each year. The only way to achieve this vision was to try and alleviate the flooding that plagues Pattaya during the rainy season. So they needed to install a new marine outfall, ensuring a better environment for all that use the beaches and all who reside there. So in my opinion, one of the highest forms of flattery that any customer can give you is to place a repeat order. It generally demonstrates a high level of satisfaction. And such is the case for this project in Pattaya. Around about 5 years ago, Uponor Infra Project Services, who I do some work with, completed its first Weholite marine projects in Thailand, which were also in Pattaya. And at that time, Uponor had been given the task of constructing 2 new outfalls as the old ones were in urgent need of replacement. So after successfully completing those, it was obvious that they were probably the best people to approach for this third one in South Pattaya. So it was the beach is located right in the heart of the tourist area. And as I said earlier, the pipeline was to alleviate an area further along the beach from the two older outfalls that had been installed in 2015, 2016. The pre-existing outfall, which had been installed many years before, had been destroyed because of the movement of the concrete collars, and they'd eroded away. And this was allowing wastewater to pour directly back to the shore without any treatment at all. And as obviously the economy is totally reliant on tourism, so to have sewerage washing up on the beach when there's people taking part in beach activities and water sports, it had to be minimized and something had to be done. And also in this particular case, it's a very, very busy beach promenade, and it could not be disrupted during these times when people were walking back and forth. And because of this, it meant that heavy lifting equipment that would normally be used for these types of applications and installations couldn't be used. And added to that was the fact that it needed to be done in what we consider to be a record time. So as we look at the bill, if you like, the bill of quantities for the project itself, it was approximately 1,100 meters of DN1800 SN4 Weholite, which was put together as 5 strings of around about 225 meters long. There was also a diffuser section and a 47-degree bend, which was added at the more or less the last minute when some services were discovered on the seabed that had to be avoided. It was installed around about 18 to 20 meters deep, and the scope of works for Uponor was the design and the calculations, obviously, and the project and site management. The materials were delivered from the Weholite licensee in that region, which is Wiik Public Co Limited, and Uponor and Wiik also offered welding services, profile filling, and submersion services. So it needed to be a fast and precise execution. This was a must in order to get this project installed safely, especially with all the tourists that were in the area. So now it was time to start the real work. But first of all, we need to take into account the major challenges that were in the project. I don't know anybody that's done any work in Thailand, but it's a very bureaucratic system to get work permits to do projects like this. They're extremely onerous. All the forms are handwritten. They have to be downloaded and filled in by hand. Numerous visits to the embassy, and as the teams were coming in from Europe, some from Spain, some from Finland, it took months to get approval. And when you actually get to the country, to Thailand, then there was a very onerous and strict 15-day quarantine with tests prior to arrival and a further 2 to 3 tests during the period. And this, of course, had quite a big effect on team morale. Now, anybody that's done quarantine in a hotel, whether it be in the UK or whether it be anywhere else in the world, can tell you that it is extremely difficult. You might have been seeing stuff in the news most recently now that UK has a red list again, but trust me, it's not something that you want to take part in if you can avoid it. So the project actually started on site around about October the 3rd, 2020, and the whole project had to be finished by December the 31st. That was the program time. It was very, very short because of all the bureaucracy that had gone on from when the contract had been signed earlier in the year. So it just kept squeezing and squeezing the window of opportunity to get this project installed. There were many site restrictions, the very busy promenade that I've mentioned a few times already, lots of tourists walking by. But this meant that the rail that we used to launch the strings of pipes had to be dismantled every evening in order to let the tourists walk past, walk by. Launches could be cancelled without warning, even when tides were good, and there were no launches allowed at weekends. The contractor was also a major challenge on this project. They had very little experience of marine work. They were becoming too ambitious. They were opening up too much trench, which would then collapse with the sea action. and thus creating extra work, which would possibly extend in the program. They also hadn't allocated enough labor to the project, and would, without warning, remove marine labor to land-based operations. And then it was just stop. You couldn't do anything on the water once those people had moved on to land. They had very old equipment, very old dredging equipment, which was generally not powerful enough, so things took longer than they should. And wooden fishing boats were used to tow the strings to the submersion sites. And just to cap it all off, the weather started to change in early December 2020. Lots more rain, the seas roughened up a bit, and there was a lot of wind about. If we add into the mix everything that was going on with COVID, all the restrictions and all the extra precautions that had to be taken on site with tests, etc., it was a very difficult project to work within. Okay, I'm just going to take a little brief few slides to, excuse me, sorry, just to explain what Weholite actually is. It's a structured wall pipe made generally from high density polyethylene, and it was invented in 1983 by KWH Pipe of Finland, who are now Uponor. I, as Norman said, used to be managing director of Ascent International, with the UK licensee for Weholite, hence my connection with the product. What's also overlooked sometimes is that Uponor are one of the largest solid wall pressure pipe manufacturers in the Nordic countries. So they also have a vast experience of installing marine projects using traditional methods for the solid wall pipe. So with Weholite, we're extruding our hollow box section, which is then spirally wound, as you can see from the video, onto a mandrel, which governs the internal diameter. And this gives us an advantage of being able to run very, very long lengths, which on marine projects can be an advantage when you can go well beyond 12 meters, for example. So in the case of Pattaya, we were running 15-meter lengths, which were being delivered from the licensee out there, Wiik. The box section increases with the diameter, and it's designed to give a constant stiffness. So it provides the pipe with a very, very good weight to stiffness ratio. And this is where Weholite excels for marine installations for larger diameters for reasons that you'll see later in the presentation. So Weholite SN4 is generally the equivalent and behaves identically to SDR26 pressure pipe, which is generally what would have been used for typical or traditional marine installations like this. It fully complies with the European standard 13476 and the equivalent, the ISO equivalent around the world, and numerous other national and international standards around the world, like the ASTM, for example, in North America. One of the most relevant features of Weholite, as I mentioned, the box profile, is the possibility to fill that profile with material to ballast it. So different densities materials can be used to counterweight the pipe and reach up to 20% counterweight. And this is based on injecting a mixture into the profile with additives that kill the curing process and keep the material flexible. The pumping is carried out with just standard pump trucks. Now, traditionally, marine pipelines need concrete collars bolted around them to provide the ballast. So, as I said, Weholite has the advantage of being constructed from the hollow box, which allows us to use this patented method rather than the collars for the submersion. The material is only there as ballast, and so that's why the reason for killing the curing process and ensuring that the concrete, if that's what's used, stays wet, and that the pipeline retains flexibility. The profile dimensions for this particular diameter, and Pattaya was the same, mean that the pipe can be ballasted up to 20% of the uplifting force. Again, it's depending on what material is used, but in this case, in Pattaya, we got it up to 20%. So this provides cost savings, but also reduces the risk across the project, from health and safety to control over the submersion process. When Weholite is welded, it becomes homogeneous, which means that the loads are evenly distributed across the whole pipeline when the material is filled into the box profile. And that means it maintains its maneuverability, making the whole installation safer. If we add to that the stiffness is also increased by up to a third when you inject the profile like we do, which provides a longer service life. But it's worth mentioning that the extra stiffness from the profile filling is not used in the design calculations because we tend to employ a more conservative approach. Okay, so back to the project. As I said, there was a long timeline from the original Pattaya installations, and the discussions about this particular project started way back in 2016, 2017. Once the project had been, the discussions had gone to the right stage, the contract was signed finally in August the 1st. But even then, there was still design work to do and calculations to get ready in order to, before we could actually decide when the start date would be. And this is where the window of time got squeezed and squeezed down to that short period from October the 3rd, or as it turned out, actually later by the time that the teams had been into quarantine. So, you know, as you know, with big infrastructure projects, they never happen when we say they're going to happen, and time tends to get squeezed, and this was no different. So some of the documentation provided by the customer were some of the reasons that things got delayed. As you can see, it's not the most presentable of documentation. However, Uponor was able to do some hydraulic calculations and downsize from the original design of 2 meter down to 1800. But it's all about getting documentation and procedures right to make the project happen as efficiently and as safely as possible. And again, with Uponor, it's not just about offering materials for the project. The scope normally involves designs and drawings, various calculations that are linked to the installation and to the performance of the pipe and its parts. Method statements and safe working procedures form part of that. And also the field services side of it, which includes welding, concrete pumping, fixing flanges and closing ends, and then installation supervision. And all of this scope has been developed by Uponor Project Services in order to reduce project risk and hopefully increase value to the client. So the project out in Pattaya was led by the Uponor project manager, a gentleman by the name of Pablo Ramon, who might be on this presentation actually somewhere. Lots of travel documentation and several swab tests, 15 quarantine days for the whole project, and then we were ready to start striking blows on site, so to speak. So towards the end of October, when everybody was allowed out of quarantine, that's when things actually started on site. And you can see from the images on the screen there, the equipment containers, the rail setup for the launch. You can see there was a shallow slope down to the beach to create the ramp and to allow the Weholite pipes to be launched easily into the sea. Just for the record, so you pick this up, that the weight of the 1800 SN4 Weholite pipe is around about 155 kilograms per meter before it's profile filled. And just to show you, give you an example of some of the equipment that was used on site. This little video of this crane starting up actually reminds me of me most mornings, but you can see that it's straight out of the antique road show this particular. But we were lucky that the pipes were manufactured only an hour away at the Wiik Public Company's factory. The work was carried out on site by two teams, one from Vaasa in Finland and the other from the licensee. Okay, so let's take a closer look at the welded joint. The teams are directly employed and trained, certificated by Uponor to carry out the process, which involves what is essentially, as you can see from the photograph on the left, an extruder on wheels that's used inside the pipes. It's an automatic robotic device, and all the parameters are controlled, registered and recorded for traceability. The process is thermofusion, and it flows through the whole depth of the profile, as you can see from the image. Apologies for the quality on the top right hand side of the slide. A full penetration weld, and this weld is stronger than the wall of the pipe itself. It ensures there are no stress points during the submersion. And this is generally because the welded string behaves homogeneously and has the same stiffness in all directions. In other words, the same characteristics and properties are held across the whole pipeline to ensure that the risk during submersion is reduced. Now, the strings were 225 meters long, and each of the strings were flanged, and they were flanged using the flange that's been designed and developed exclusively for the Weholite marine system. It's been used successfully for many, many years. It's a combination of a socket joint and a flange connection. On the female side of the flange, it's fixed, and on the male side, it has a loose floating flange to allow it to be rotated and to allow for easy alignment underwater when the divers are assembling it. It's delivered in 2 halves, obviously, to allow for easy transportation anywhere in the world. And then it's bolted around the pipe. It has seals sitting under it so that you get the 100% watertight joint. And once the flange ends are assembled around the pipe, they can be fixed to the Weholite pipe by filling the rectangular holes with extruded HDPE using a fusion welded system. This provides more than enough strength to pull the pipelines together underwater, and the function is generally carried out by trained divers either just under the surface of the sea or on the seabed. Calculations are carried out, corrosion calculations of the steel to ensure that the asset life is met, whether that be using anodes or spray coatings or whatever it may be. In this particular case, the asset life that had to be met was 40 years. So on to the ballasting methodology. In Pattaya, we were able to source ballast material from a local power plant. It was fly ash, and this was easily pumped around the profile. You can see the pump trucks in action and the photographs on the left. So the holes are cored in the profile, and the material is pumped in, and then the holes are filled up again with a plug, as you can see, generally, which is then welded over. And this allows the pipe to retain its flexibility for the S-bend submersion while still having the weight to submerge it. So the specific gravity of the material was between 1.8 and 2.1, allowing on average around about 20% ballast in weight, which is the optimum really. This made the weight per meter of the pipe, if you remember, 155 kilograms, the pipe unballasted. When it's got the fly ash in it, it was achieving just over 1 ton per meter. And this is more than enough for submersion purposes. We were able to ballast around about 200 meters, almost one full string per day, using the pump trucks, shuttling back and forth. Of course, when the pipes are ballasted, the flange is fitted, the ends have to be closed prior to the launch. The reason for this is to sit it higher in the water. It allows for easier towing, and it allows for controlling the S-bend submersion technique much easier when you allow the water into the closed off pipe. Generally, the plates are cut out by divers using a chainsaw after the pipe has been partially submerged. However, since this project was done, actually, we've developed a new system, which is a bolted system, so the plate can be removed simply by undoing bolts, rather than allowing a diver to use a chainsaw underwater. So then we come to the launching of the strings, and a lovely video filmed there with a drone showing the beach in Pattaya. Fantastic. So obviously we have a barge with a winch on it, in this case, generally pulling out the string out to sea, get the momentum going with the buggies placed on the rail track around about 5 meters apart. And once the momentum is going, it's quite easy to pull the string out to sea, as you can see, without the restraint of any collars. It tows quite nicely out there. Of course, that's usually when the contractor decides to turn up. We had one particular instance where the contractor didn't turn up, which caused a bit of an issue, which I'll explain in the next slide. We were all set up on one particular string to launch at around about 9 a.m. in the morning, which was high tide. Unfortunately, the marine contractor didn't turn up with their equipment until 5 hours later, thus making the launch much more difficult, as you can see from the photographs. We had to get some cranes in to lift it over the beach there into the water and get it back out to sea. And that shortened the window of time we were looking for on every string to submerge. So towing the strings, the distance from the welding site to the submersion site was around about 15 kilometers. You can see from the little line drawn on the Google Earth there, that's more or less the route that was taken. There's the submersion site, and there's the welding site there. So each string weighing around about 230 tons with a ballast in it was towed by wooden fishing boats at around about 4 to 5 knots. When we were looking, probably a bit quicker when we weren't looking, to be honest, but 4 to 5 knots is generally the recommended speed for towing the strings around. Of course, as we entered December, as I said, the weather turned a little bit, the seas roughened up slightly, and the winds and the rains took over. Now, the reason I'm showing this video, and you can also see the gentleman trying to surf the pipe in the video, is just to show you the mentality of the contractor and the disregard for health and safety. Do what you might to advise. Obviously, a lot of it gets ignored, but it just gives you an image of the challenges that you come up against working in these parts of the world. Okay, so the first string to be attached is usually attached to the concrete chamber, distribution chamber. In this particular case, this was no different. So what we tend to do is we cast in the female side of the flange into the concrete chamber in advance, as you can see from the photographs there. And this means that the first string can be pulled into the flooded trench, connected up quite easily with the flange system that we use, get the alignment right, and then the rest of the outfall can be laid safely off that first string. So the pipes are normally launched with straps and brackets to attach inflatable airbags. The pipes, with the pipes over the submersion site, the inflated airbags are attached, and then the water filling can begin. Now, in this particular project, we specified a pump with a certain capacity to fill the pipe string up and get it under the surface of the water. Unfortunately, once again, we were let down, and the pump specification was not available. We weren't told until the last moment, which meant that the pumping took longer than planned and obviously shortened the window of time for submersion. So as most of you experts know, the S-bend configuration is a balance between the forces acting downward, fill profiles in the case of Weholite, and the forces acting upwards, the buoyancy of the air-filled pipe section. With the pipe diameter, the 1800 pipe that we used at Pattaya, it was necessary to fill it completely with water in order to reduce the uplifting force and get it under the surface. The airbags are used to compensate the load of the pipe string under the water. And then when we empty those, it's possible to tightly control the bending radius and the position of the pipeline as it slowly sinks to the seabed. And these diagrams that you can see on the left-hand side explain it far better than I can. You can see the pipeline being filled with water using a pump. Obviously, air is allowed out of the other side of the pipe. This is generally done by divers. And you can see then the slow submersion. This is the preliminary sinking, which gets the pipeline just under the seabed with the airbags full. And then we move on to the full submersion, which allows the airbags to be slowly deflated and the S to start. The slideshow sort of shows what we're doing as best as I could manage it without filming underwater. And you can see that the pipe then slowly sinks in the shape of an S down to the seabed and into the trench, until it finally rests on the seabed and in the trench. Once that's done, the divers can go down and assemble the flanges. The flange, as I said, is the male section is a cone shape, and with the floating flange, male flange, which rotates around the pipe, you don't get any issues with misalignment underwater. So it makes the job easier for the divers to assemble those flanges underwater. You know, when you're using a standard type flange, it becomes very, very difficult. This is specifically designed with a connection mechanism to make life easier for the divers underwater. And in the case of this in Thailand, it was no different. The strings were assembled fairly efficiently. So once the pipe strings are in place, then the backfilling can start. The pipe in this particular case was laid in a dredged trench, and the trench depth was around about 4 meters to pipe invert, meaning that on the whole, we had an average cover between 1.5 and 2 meters of the ASDUG material, which was mainly sand in this case. We allowed a 24-hour window for each string from the launching at the welding site to the backfill completion, which turned out to be, even with the delays caused by the contractor, it turned out that it was more than achievable for this particular project. The final piece of the jigsaw, the diffuser, was a section that was 16 meters long with 4 ports of 1,000 millimeters diameter. The section is lowered on its own down to the end of the pipeline into the trench. The main flange connected by divers, and then once that's done, once it's got some backfill over it, then the risers can be connected again by divers, as you can see from the diagram there. So in summary, the duration of the project was reduced by 50%, and by having the Uponor team on site supervising the installation, it gave the direct information, if you like, to the client, and made them feel as if they were more in control of the works in real time. So the tight challenges posed by the pandemic didn't really phase the teams once they managed to get out of quarantine, that is. Everything was completed on time, and in this case, happily, everybody was at home for Christmas 2020, even though Boris had cancelled it, I believe, in the UK at the time. Ironically, the Outfall didn't go into service as planned on December the 31st because of a new COVID outbreak in Thailand, forced them into a temporary lockdown. So it wasn't until a month later, at the end of January, that they actually switched on, if you like, the Outfall. And again, despite the obstacles, the system had shown its credentials on a major infrastructure project, and it's working today, and hopefully keeping the beaches cleaner and healthier than they had been previously. Thank you very much, everyone, for listening to the story of the Pattaya Outfall. And if you have any questions, please feel free to ask. If I can't answer anything, then I'm surely will come back to you at a later date with the answers.
Sorry, Simon, I forgot to unmute myself. Thank you for a really interesting presentation. If I can ask, the participants, if you'd like to put your questions in the chat. I've got a couple myself, so I'll sort of kick it off. I just wondered what length of pipes do you normally manufacture? Because you obviously showed your robotic welding machine welding those together on the surface.
So coming off the production line, if it was a standard sort of land installation, let's use the UK as an example, we'd probably be producing up to 14-meter lengths. When we did a big marine project back in 2012 at Beckton sewage treatment plant, and we supplied 18-meter lengths by special license. I can also remember doing a 25-meter length up to Davy Holme treatment plant up in the northwest. Yes. Yeah. So it's essentially any length you want, providing we can transport it.
Yeah. And then I just wonder, obviously, filling the profile, that's quite interesting. And what was the frequency of the injection points, and were you able to sort of check how effective the filling was?
Yes, obviously, when we initially developed the system, we were actually drilling at every profile to make sure, you know, that it was expelled. But experience, because we've been using the system now for, it must be 20 years, I think. Experience has told us that we can drill less holes along the profile and ensure that the air is expelled and that the whole profile is filled. So, for example, we're pumping in at one end, and we have done just a vacuum pump on the other end.
Oh, okay.
The pipe, yeah.
Oh, well, that's interesting. Yeah, and then, well, one final one from me was really, and I'm not experienced in marine pipelines, so you have to excuse me if I'm being stupid, but I just wondered why you're installing it in 225-meter lengths, and why you couldn't do the flange joints, say, on a barge, and rather than having divers.
Well, the system allows you to sort of easy installation, and it's much easier to allow the string to go down to the seabed or just under the surface and pull the pipe in the water, rather than assemble the flanges, lift it out of the water, where you've got more pulling force needed to pull them together, I would think.
Right.
Okay. So I think traditionally with marine projects, they are assembled underwater.
Right. There's a couple of more questions come in the chat now, so hopefully I've kicked people into thinking about things. The first one is, were you encouraged to use the local marine contractor?
Yes. Yes is a simple answer. It had to be done with a local marine contractor. Yeah.
Yeah. That would be probably from the local government, was it? Yeah.
I couldn't possibly comment. But but what I will say is, obviously, part of the Uponor project services scope is to provide installation supervision.
Right.
So you try and do the best you can to advise on various things to ensure that it's done smoothly.
Yeah. And then another question is, what additional measures are required to achieve a 60-year design life or more?
Well, the pipe will achieve, the polyethylene pipe will achieve 100 years without any additional sort of measures, if you like, as we know the nature of polyethylene. In terms of the flanges, it could be anything from thickness of steel to coating to some sort of electrolytic, you know, to protect the galvanizing coating, anything like that, really. The calculations are done by cleverer people than I. When we did, again, sorry to refer back to the project in Beckton, what we did there was to, with the flanges, because the Thames Water wanted 100 years, we encased them in concrete, in polyethylene boxes, which were filled with concrete to protect the steel flanges.
Okay. And then, well, there isn't another question, so I'll ask. Okay. Just if you were going to use the Weholite, let's say on you know, on normal terrain, not marine, could you obviously install the pipe and then place the the filler inside the profile afterwards? Is that feasible?
You wouldn't on a land, if you're talking about a land situation, you wouldn't normally use the filler.
Right.
There wouldn't be any need, because you'd be installing in a trench that would essentially not move.
Yeah. I was just thinking of improving the ring stiffness of the pipe, particularly if it was a relatively
okay.
deep.
Okay, well, obviously the ballast improvement of the stiffness of the pipe stiffness was more of a byproduct, if you like. So we don't take that into account with the calculations. If it was a land-based situation and we needed a stiffer pipe, we just use design a stiffer pipe.
Right. So what's the maximum SDR of the Weholite that you manufacture?
You've got me there, because I'm not a solid wall person, but in terms of stiffness,
we've
actually designed I think it was a project in Scotland many years ago with Black & Veatch. I think it was an SN16.
Right. Yeah. Okay.
Yeah.
Okay. No, I'll just say you probably know my background. I was at Subterra, so
Okay.
a lot of experience of installing sort of solid wall PE. So yeah. Okay. Right. Well, I don't think there's any other questions posted on the chat, Simon. So if that's okay, I'll bring the session to a close now, and I'd like to thank all the people who've joined our webinar today, and I hope you agree with me that it was a splendid presentation, and I'd like to thank Simon for taking the time out of his busy schedule to provide us with such an interesting presentation. And again, just as I said earlier, bring your attention to the program of events that we've got coming up, particularly in 2022. The next webinar we've got is on the 25th of January. It's the development of strategic water resources in England, and we've got Julian Wellbank, who's the director of Wellbank Water Consulting, presenting, and that will be hosted by the Eastern branch. Then on the 10th of February, we've got our London Showcase and Lions Lair, which we jointly host with the Southeast branch of IGEM. And we've got the keynote speaker, Hilary Buxton, who's the Director of Engineering at Cadent. Then on the 8th of March, we've two events. We've got our main event, which is our 64th Guild dinner. We've got tickets on sale at the moment, and we still have some sponsorship opportunities available. And then just prior to the dinner, we're running an innovation achievement seminar, which is presentations from our 2021 Guild Technical Award winners. And then finally, just an advance notice of our Guild conference, which is taking place on the 11th of May, which is the skills needed to meet the challenge to reach net zero. And that's taking place at the MTC Conference Centre in Coventry. We've got two keynote presenters. We've got Steve Fraser, who's the CEO of Cadent, and Richard Price, who's the COO of Bristol Water. So I'm sure that will be a really interesting event. And then we've got an array of other speakers alongside our national PDN competition. That event is free to attend for PDN members, and we're now looking for the sponsorship for the event. So if that is of interest to you, then please make contact with us. The sponsorship comes with an area for exhibition and the like. So so please come to the HQ staff for details. And then, as I said earlier, you can get all the details of these events on our website, pipeguild.com, and also if you look out for our posts that we have via the email or social media, particularly on LinkedIn. So finally, I'd like to thank you all for attending and supporting the Guild. We value your feedback from all our events, whether it's good or bad. So please let us know what you'd like us to cover in our program going forward. And we're always happy to speak with members, so please don't hesitate to contact us as HQ. So I'll thank you all again. I hope you all have a really good Christmas and a happy new year. And I hope you enjoy the rest of your day. So thank you very much.